Hi guys, Gabi from UiPath Hacks here. If you are a beginner UiPath developer that has already created some simple workflows and is now looking to create some more production-ready automations, this is the video that is the right next step for you. I will explain here the structure of the UiPath RE-Framework, the way it works, what are the areas of the framework you need to interact with, and I will also provide a simple demo that you could recreate by yourself and get more confidence with using frameworks. So first of all, why use RE-Framework? RE stands for Robotic Enterprise. It's all about exception handling and logging and building a robust automation. The template has built-in placeholders for reading config data, opening and closing applications, getting the next transaction and processing it. And when required, it allows to also retry some transactions. Furthermore, as this is a standard template, which each company may decide to modify and vary a bit, but still to be pretty standard overall, it becomes much easier to follow the thread of an automation, understanding what it's doing and knowing where to expect different pieces of code, even if you are looking at an already built automation that is new for you. So it, in a way, introduces a kind of a common language or common strategy across developers of UiPath. So let's look at the general framework architecture. You have probably heard the term state machine related to the framework. What does it mean? A state machine is a type of automation that uses a finite number of states in its execution. It can go into a state when it's triggered by an activity, and it exits that state when another activity is being triggered. An important aspect of state machines are transitions, as they also enable you to add conditions based on which to jump from one state to another. These are represented by these arrows or branches between the states. There are 4 machine states in the standard template, and the bot will find itself in one of these states at a given time and will navigate between them based on these transitions. So the template also comes with a config file. Let's have a very quick look at it. It's found in the data folder of the framework. So we have 3 sheets in the standard config file. We have the settings sheet, and the most important setting here or parameter is the orchestrator queue name. So this value here we would have to replace with our queue defined in orchestrator, and we will do it a bit later in our example. And then we can define here different other parameters with their values and some descriptions. So we later on remember what that parameter was doing, why we have added it there. And the purpose of this is to avoid hard coding in our automation. So anything that you might have hard coded in a simple automation that you want to develop and move to a framework format, you could add here to this settings sheet. And we will do it in our example a bit later on. Then we have the constants sheet. One of the important ones is the maximum retry number. So how many times an item would be retried by the framework. And we have an explanation here, which is very helpful. So if we are working with orchestrator queues, this must be 0 because we define the maximum retry number in the orchestrator queue itself. So that will anyway override this. But if this is number it's higher than 0, then the robot will try the same transaction which failed with a system exception. So if you're not clear on what a system exception or application exception means versus a business exception, I've already created a video about that, and I will link it in the description, and you can also see it in the upper right hand corner of the video. Because a system exception, the framework would try to reprocess. It could be that, the browser window crashed, and if we just restart the browser, it will work the second time. Whereas a business exception, it's linked to something in the data, which is wrong. So if we try to add an integer and a string, it will fail the first time and the second time as well. It makes no sense to continue to try to add them up as numbers, for example, if one of them is not a number. So that's the distinction between system or application exception and business exception. So if we are using a queue, we don't have to care about this one. If we are not using a queue, we can define here how many times we would like the framework to deal or to process an item. And then the assets sheet here, we can define orchestrator assets. We can put here the name and the asset, and they will be pulled from orchestrator. And the reading of this config file is already built in the framework, and that is very nice that we don't have to care about it anymore. So let's start looking at it. Let's start with the initialization state. You can just double click on it and it will open its implementation. So what do we have here? We are initializing the system exception with nothing. If an exception is triggered, then the system exception will get that value of the exception. So if there's no exception, we continue. We have here some actions. Basically, we are invoking the init all settings workflow. We can open it by clicking this button. So let's see what we have here inside. We have an object, an outConfig object. When we have here this prefix out or in, we can immediately think about arguments. So this means that this config is an out argument. We can open the arguments tab. So we have the outConfig argument, and the fact that it has an out as a prefix shows us that it's an argument. We can see it here. It's a dictionary of string and object. So what is an argument? An argument is basically a type of variable which is being passed over or between different workflows. And we have a number of workflows in the framework. We can see them here on the project pane. Yeah, we will go through all of them. We have quite a number of workflows which are communicating between them. So we have this outConfig parameter. Basically, this init all settings workflow is reading the Excel file, the config Excel file, and it will be passing back the values in the form of a dictionary. So it is reading here the config file for each sheet in the in config sheets. So we see another argument here. This time it's an in argument is being passed to this workflow. One thing we could do is to click this import arguments, and we see the arguments that this init all settings workflow receives from the main workflow that it's calling it. So we have the in config file, which is the Excel file here found in data. Then the sheets. One interesting thing is that it is only passing the settings and constant sheets and not the asset one. We will see why. And then it will receive back the outConfig object of strings and objects. Yeah, so it's receiving basically the path of the config file and the sheets that it needs to read. And it's doing it here. So for all this, or for both of these sheets, it is reading the information on the sheet. It is saving it in this settings and constants data table. And then for each row in this data table, then if basically the row is not empty, because we can have some empty rows here, like this one, just to kind of group our settings together nicely so they're very visual. So for every non-white row, it is saving or adding this key value pair in the dictionary, in the outConfig dictionary. And then we're treating here the assets differently, because for assets we need to get the values from orchestrator. So now we are reading the assets sheet in the config file separately, and for each row in the asset sheet, it's getting the asset from orchestrator, its value, and then we are also adding in the outConfig dictionary the name of the asset and its value. So this is the part that reads the config file, and we see here built in something about exceptions. So we are catching an exception. If it's just exception, it means it's a system exception, the most generic one. And yeah, if we have any exception like that, it means that no assets are defined for this process. Yeah, so it will catch it. We'll just log that and will not have the process stop. All right, so this is the init all settings workflow. So we can continue with the initialization state here. Let's see what's next. If there is a queue name specified, it saves this queue name. This is in config as well. This is kind of a backwards compatibility with an older version. So that's just here for backwards compatibility. And then the next step is to invoke the kill all processes workflow. This is because, let's open it and have a look at it. Basically, it just contains here a log message, and here we could put our activities to kill any processes which are being used by the automation. Why do we want to do this? It's because we want to make sure when we initialize our automation, we want to start with a clean state. Regarding the apps used in this automation, especially if the framework would encounter somewhere in the process an exception and would need to restart. And then when it restarts, it is going basically back. Maybe it encounters an error here or here, then it would go back to the init state and try to restart and reprocess the same item. So when we're going back to the init state, we want to make sure that we start in the same state, with the same settings, with the same applications open or closed, so that it will provide consistency. So the next step after killing all the processes is to initialize all applications. Let's open this. And this is a placeholder for us where we can open all the apps used in our automation. Let's say it could be an ERP system like SAP. It could be a browser, especially if opening some of them requires a bit more time. However, we are not constrained to open all our apps here. It might be practical to open some of them later on in the process, especially if we don't plan to keep them open for the duration of the whole automation. But if we need an application for the whole automation, it is good practice to open it here so we know where to look at if we need to deal with that. So that's basically what we have in the initialization state. And if we look at it, all these steps are wrapped in a try-catch. And we are catching here the exception, also the system exception. We see here that the system exception variable gets the value exception. Basically, we are making sure that if anything goes wrong, we can log this system exception. However, we are here in the init stage. So if we can't get past the init stage, it makes no sense to try something else. So we are looking now at the transitions. We have a successful transition. Let's click on it. Let's see what's happening. Basically, if the system exception is blank, then we go to get transaction data to the next state. If we have an error or the system exception, then we go to end process. So if we have an exception, if it is not nothing, then we go to end process. Because if we are in the init stage and we can't even get past this step, it makes no sense to try to get transaction data. We go to end process directly because it's nothing more we can do. So this was basically the initialization state. We have seen what we are doing here in the try block. We've seen the exception and as well the transitions. We can move on and look at the end process now. This is rather simple. We are basically invoking here a workflow with no arguments to close all applications. So the applications that we have opened in the init all applications workflow should be closed here, just to ensure that after we finalize our automation, we leave the system in the same state it has been before we have started our automation. And we see that calling this workflow is also wrapped in a try-catch. We have an exception here, a system exception as well. We are logging it. And if this fails, then, so basically if closing all applications elegantly fails, then we would jump to the kill all processes workflow. And this workflow basically kills them by calling the process name. Again, just to make sure that we are leaving the system clean. So if one application hangs, for example, and we try to close it properly and nothing happens, then we can use the kill command and make sure that it's being closed as a process in the operating system, rather than leaving it hanging after our automation finishes. So if we look at the transitions here, we have none because this is the end state. It's a special state. When we get here, the automation finishes. All right, so let's clean up here. Let's go back and let's look at the get transaction data. So in this state, we have the logic that gets the next available item, if any. It starts with this check stop signal. This is basically checking with orchestrator and giving orchestrator a chance to stop the automation if needed. Now in orchestrator, we have two ways to stop an automation. One of them is to stop it elegantly it means that when it gets to the next item and it tries to fetch the next item, it will check this stop signal and say, oh, orchestrator wants me to stop. So it will just finalize the automation. From orchestrator, we can also use the kill process command, and that will just kill the process at that second, let's say, and just close everything down, but not properly, not elegantly. So this check stop signal allows orchestrator to send this message, hey, when you finalize the current item and you are looking to start a new one, don't just stop there. So if we have a should stop, then basically the transaction item becomes nothing, and that finishes the automation by moving to the end state and closing down everything there properly. If we don't have a should stop signal from orchestrator, then we are invoking the get transaction data workflow. Let's open it. And here we have the out transaction item. Let's look a bit at its parameters, at its arguments, because this is interesting. So we have here the in transaction number. We're getting a number. We're getting the config file, of course. And then we are passing out the transaction item as a queue item, and some IDs that we can assign to it if we need to, and as well the transaction data table. And the most important here would be the transaction item, because that will be passed over to processing that specific item. So if basically the transaction item is not nothing, so we have something there, then we get the ID by the current date and time. And we could use these additional fields to store in some more metadata. Like we have some explanations here. If, for example, we are doing an automation about invoices, we can maybe store here the invoice number, just have a reference to it when we are debugging, or a date or an amount and stuff like that. Basically, we are getting the transaction metadata here, and by default, the get transaction item gets a queue item. And we have here the queue name from the config file, and it saves the queue information on this out transaction item argument. All right, and if we are successful, then we move on to the process transaction state. And if we have no data, we move to the end process state. And in terms of exceptions, we have here again a system exception. What happens if basically we have no more transaction items? All right, so now we can move to the last state, which is the process transaction. And here, normally this contains the logic of processing a single transaction delivered by this previous state. Okay, let's open it. We have here the business exception, which is initiated with nothing. So this is where we first encounter a business exception as well, as opposed to only system exceptions that we have seen so far. And for the explanation of the usage and difference between the two main categories, I've mentioned in the beginning, I've created a separate video. Please go and check it out. You would find it in the description below, as well as in the right upper corner of the video. It will clarify a bit more what is the difference between the business and the system exceptions, and what is the effect on automation. When do we want to continue and rework a certain item, and when it makes no sense to do that. So please check this separate video about application versus business exception. So basically here we invoke the process.xaml file. We are passing two arguments, the in transaction item, which contains data from the queue item, and as well the config file. And this is the workflow that will contain the meat of the automation. So basically, most of our automation will be here. We'll have different workflows invoked from this process workflow. As transitions, we have 3 transitions this time. If we have a system exception, we go to initialization. If we have a business exception, we get to transaction data. And if we are successful, we get also to the get transaction data. So you see, if something crashes in one of the applications, then we try to reinitialize and maybe rework the current item based on the settings in the queue or the config file. But if we have a system exception as well as a successful transaction, in both cases, we go and fetch the next item, because if we have a business exception, it makes no sense to try to reinitialize and try to process the same item. We can move on to the next one and just log what went wrong with the current item. And also we have 2 catches now. We have one catch for the exception, system exception, And we have one for the business exception, where we're initializing these variables with an exception. And we have their types here. So we have a business rule exception type and a system exception type as well. All right, so that concludes the overview of the RE framework. We've gone through all the states and the transitions. We have seen the config file, and we are now ready to play around a bit and take an existing workflow and try to convert it to a framework implementation to make it more robust. And for that, I've already built a very simple workflow here called adding up. Basically, here we are reading an input data, an Excel file. We have it here in the input folder. It's a very simple Excel file. We have two columns, A and B, and we have some numbers on each of the columns. And we are reading these two columns. We are adding then a third column called result to this data table, DT input, which is being created here after reading the Excel file. And then for each row in the DT input, we are assigning to the result basically the sum of the first two columns. And at the end, we're writing the data table in a new file, output data, in the output folder. So let's run this quickly. And let's go to the output data folder, and this is the result, summing up the first two items. All right, this is a very simple workflow. It would be a bit of an overkill to move it to a framework, but still, just to demonstrate the usage of frameworks, it makes sense to take a very simple example and move it to a framework and focus on the framework itself rather than take something complex as a first example and get lost in the details of the complex automation, and then on top of that come with the complexity of the framework. And actually this is something that you might do quite often in the beginning when you have already built some automations which work, but you want to make them more robust now and move them to a framework implementation. And this is a good example of what you need to modify when it comes to an existing workflow that works to add it to a framework and see which blocks you have to move where in the framework to make it work. So let's start with setting up the config file, because we have here some hard codings in our automation which I don't like. For example, if we look at reading the file, we have here the workbook path, which is hard-coded, and it's good practice to move that to a config file. So we have everything in one place and easy to modify it later. So we can go to our settings and have here a setting, a parameter called input file, put here the value and a description, path to the input file. So we have added the input file parameter. We can now do the same for the output file. All right, and we would also need to update here the queue. Let's do that. Basically, we have to define a new queue. Let's say summing up, that will be the name of the queue. We have created the queue, and now let's paste here the name of the queue from orchestrator. Right, so that should wrap up our config file settings. Okay, so what we need to do is to basically split up this adding up workflow. We need a workflow that feeds the data to a queue. We need to build that from this. And once the data is on the queue, then we can run our main workflow that will pull the data from the queue and process it. So basically add up the items. So I would just create here a new sequence. We can call it dispatcher. Basically, we will have a simple here version of a dispatcher performer, a pattern here, where we have a workflow. It will be very simple with no framework in this case. feeding data to a queue, and then the performer or the worker or main process here fetching the data and performing the activities, in our case just adding up the numbers. So let's have a dispatcher workflow here. This workflow will read our file, and it would then go through each row of the data table resulting here. We have to define our data table as a variable as well here. This data table. All right, and then for each row in the data table, it will not do the calculation, but it would add the item to a queue. So we have this activity here, add queue item. We have our queue name here. It is called summing up, I think. Let's check it. Summing up. And the item information, we would create here an argument called A, and we will do one called B, and we'll do one called result, which will be blank. They will be all integers, and we need to put here the row A, and we can just make this an integer. All right, so we are basically saying here we want to take the value on the row on column A, make it a string first, and then convert that to integer. Make sure that we have an integer value here on the queue. All right, so we are adding the two values to a queue, and that's our dispatcher. Should be fine. Let's try to run it. And successful, no issues. Let's look at our queue now. And we see here 3 items that were fed by our dispatcher workflow. You can see the details. We see the numbers from Excel, and we have a result of 0. We probably need to add the result at this stage, but anyways. Now we can go back to our main workflow here, and we will be getting here already the items from the queue. So what we need to do is we will have the items in the in transaction item, and we just need to do the summing up. We don't need to take the for each row structure from our initial workflow, because we already have the one row fetched from the queue, basically. So we could build a data table and we will have here column A as an integer and column B integer, and we can add another column which will be the result to be an integer as well. All right, we have our data table, and now we would want to add a row to the data table. We have here the dt input data table. Actually, we have to create a variable dt output this time. This will be the output data table. We have here dt output. We have to add up the values, and we have to pull them from the queue. So for that we have the transaction item argument. We can use it here, and then we have the specific content method, and now we can pull basically the label A from the queue. So this is our queue, and here we have this one, this field, and this field. So we're pulling now the number that is stored on column A in the queue, and this will now be converted to string, and the whole thing we can convert to integer. I will just take this from here and wrap this whole thing. So we have an integer here. Then we would do the same for B. Sorry, so we have to put actually the whole string not in the data row but in the array row, because we are feeding it an array. So we are feeding it A, B, and then here we have to put basically A plus B. A plus B, the sum. So we should be good now. It looks rather complex, but it should work. We can delete this value here. Alright, so we are adding a data row to this table. And then what we can do is write this in Excel file. Should use the workbook one, so we have also the Excel name. Here we have to give it the path, and we have it now in our inconfig parameter. So we'll just do inconfig output file, I think it was the name, and to string. Let's check that. Output file, yes, correct. And then in sheet 1 we would add our data table, which is dt output. So what happens for each item? Basically, we are building a data table with one row and appending that row at the end of the Excel file. So that should be it. Let's try to run this. All right, so the framework has run. We see here it has processed transaction number 1, number 2, and number 3. And so let's check our output data file, and nothing happened. All right, let's see our input. We have a different file here with the result. So apparently something went wrong with our paths. I will delete this. Let's check our paths. We are using the output file here, path, and that's, 1 second. Yes, so this is our mistake. Data output data. So our path was wrong. Let's run again. And now for running again, basically our queue items have been processed already. If we refresh this, look again, we see that we have no more new queue items. All of them were processed successfully. So what we need to do to test again, we have to run our dispatcher again. This will read the data from Excel, from the input Excel file, and create new queue items. So let's do that now. It has finished running, no error. We check our queue. We have 3 new items. So we can go ahead and run our framework again. It has run successfully. Again, 3 items processed, no errors. Let's look at the result. Output data, and now we find our results here. 4, 8, and 2. 1 second. That's something strange. So we did a mistake, because we should have had 1, 2, 3, and we have the 2, 4, and 1 repeated on the second column as well. So something is wrong with our reading the data, I assume. Let's check the queue as well to see where the error was. The queue is fine, so we are passing the right values here in the queue. It means that in our process here, when adding up, we did something wrong. Adding data row. Yeah, so we have A here, this is the mistake. We have to put B. And we have to add up A and B, not A and A. All right, so another mistake, but you see what was fairly easy to spot it, to know where to look. So that means that we have to run the dispatcher one more time. This would create new queue items, and now we can go ahead and run our main workflow. And let's see what happened with our output file. Yeah, so we see it has kept the first 3 rows because we keep appending to it, and in the second run we have now our correct values here. We can of course flush or recreate the output.excel file, but that's not the focus of this example. So we've seen how to move basically a very simple workflow of adding up 2 items from an Excel file to dispatcher performer design pattern and building the performer as a framework. And we have here a lot of exception handling and logging. We see the logging already, some very basic logging here, but we have a lot of exception handling. So I'm wondering what would happen now if we try to mess up with the data or the file. So let's see what happens if we tinker a bit with the system. Let's see what would happen if we basically change here or kind of keep this file open and keep it blocked, yeah, and run first the dispatcher to create some data on the queue, and then run the main of the framework. So basically the process is finished due to no transaction data. Let's see why. Because we have here an application exception. Yeah, we've had an application exception. So we have refreshed now. We've seen that we have 3 failed items, and the reason for that is we have here the exception reason. The process cannot cannot access the file output data because it's being used by another process. So we see that our workflow has not crashed. It didn't do anything. It said no transaction because it has encountered a system exception. So that was it pretty much. Thanks for watching. We've seen what an RE framework is, when we should use it, what is its structure, how it works. We've seen also an example of moving an existing simple workflow of adding up some numbers from Excel file to a framework and using dispatcher, performer, design pattern. So I hope this was useful. You probably have some similar cases where you'd have to move your existing workflows to a more robust framework implementation. If you enjoyed this video, please hit the like button and consider subscribing to support the channel. This would help the channel greatly. Thanks for watching and have a great day.